Dr. Babasaheb Ambedkar Open University.
Welcome again. We are starting with software engineering block 2, which is about software quality management, right? And we are starting with unit 1 right now, which is about software quality management and a few of the testings that we will see, right? Now, in this particular unit, you will be seeing what is quality management process, all right, how to manage my software, right. So, software quality management has a particular process. So, it describes software quality management process. Then second one is quality management activities, what are the activities associated with my quality management, right. Then we will be seeing the role of standards in quality management, what are the standards to keep my quality, my software quality management, all right. Then we will be seeing concept of software metric, predictor metrics and control metrics, what are metric, predictor metric and control metric, right. Then we will be seeing and having idea about the measurement in assessing the software quality, all right, because software quality is one of the essentiality of my software project, right, the developed software, right. So, we will get the idea about the measurement in assessing the software quality. Let us start with unit 1.1, which is an introduction of software quality management. Starting with this, software quality management is related with ensuring the required level of quality which software should have in order to work with its product. Alright, so what quality it should have? My software which I have developed, what is its quality? Whether it is highly qualitative, or whether it is having medium kind of quality, right? All that is ensured with my software quality management. Alright. Over here in the diagram you would be seeing there is quality assurance, there is quality control and quality planning, right. Now, assurance is something that we give that yes, this is particularly having this much of quality is assurance. Quality control, what all controlling mechanisms we require to provide certain kind of quality, right. And quality planning, what are the plans to provide certain quality, right. I would like to give one example for this. We generally take clothes, right, and all those clothes have different kinds of quality, right. For example, if you are buying some kind of cloth maybe from a merchant who is not so well established, then probably you would get a kind of a cloth product which is not more qualitative, but if you go to some branded store you would get a good quality cloth, right. So, that is quality. Appropriate quality standards and procedures will make sure that such quality standard in software needs to be adopted, all right. And quality management activities as said are three, first being quality assurance, second being my quality planning and third being quality control. So, all these three different activities are main pillars for my quality management. I assure for my quality, I plan out for my quality and then I control my quality are three different steps of quality. Now, what is assurance? Assurance is something that you are going to provide to your customers that my particular project or my particular software will have this much of quality is an assurance, right. Then to meet that assurance level, whatsoever you have assured, to meet that level you plan out that what all measures should be there to provide certain kind of quality. And third is control, that when you plan it out, all right, to give that particular quality, what are its controlling mechanisms, all right. Let us see and start the unit elaborately. First, unit 1.2 is about software quality, all right. Software quality depends on internal and external factors, all right. Just like what your cloth quality depends on internal factor and external factor. For example, if you are wearing some cloth, all right, that cloth from where you bought it, all right, is something which is an and what kind of cloth it is an internal factor. External factor, when you wash it off, do you wash it very roughly or maybe you are always doing it a dry clean, right. So, that is what is internal and external factors. So, similarly my software quality also depends on two kind of factors, internal factors and external. Let us see what are those. External quality includes user experiences in running the software, all right. So, in this my end users are included who run this software, all right, and they say that whether this particular software is of a good value, is it giving a better performance, all right. So, the main aspect to the end users. So, external quality is a main aspect to the end users. So my end users, whatever their experiences are there, whether experience is good, whether experience is low, whether experience is quite worse, right. So that depends on my, and that describes my external quality. The internal quality refers to designing of software by use of codes. So my internal, that means whatever the code that I have written for my software, alright, whether that code is qualitative, it doesn't have any error, it doesn't have any bug, right, all that comes under internal quality of my software. And the main aspect of internal quality for the is my software developer, right. So software developer are the one who describes and who proves the internal quality, and my end users are the one who proves and enhances and approves the external quality, right. Next is software quality depends on 3 prime factors. What are those 3 prime factors? Let us see. First is testability. My particular software should be testable enough, okay, and whenever it is tested, it should pass all the tests, okay, all the tests should be passed out, alright, that those are called as test cases rather. So that ensures my testability. Then next is coverage. Whatsoever my software is there, alright, and my software has, I am saying that my software provides with certain characteristics, certain features, then all those features are present into it, whether all the features are covered in my software or not is called as coverage. And third is flexibility. My software should be flexible enough with any kind of system that it is, it is designed for, alright. So there should be flexibility in my software. That 3 parameters describes the quality of my software, alright. Then criteria to be followed during external quality, alright. When I am supposed to build up my external quality, let us see a table which says that what all criteria should be there, alright. It is user, the developer, alright, user with perspective to the external inputs, or sorry, external qualities, developers being with the perspective of internal quality, and the measurable, alright, whether it is yes, somewhat, no, whatever, alright. External qualities are features. Users cannot say that I want, I am going to put out this feature, no, it is the developer who does that, alright. Features, yes, user does it. Speed, user checks whether the speed of the software is there or not. The developers also test whether the, a particular speed is retrieved out of the software or not. And measurable, yes, yes. Space, yes, my user does it, developer also does it. Measurable, yes. Network usage, alright, whether my particular software is going to use network, user also checks, developers also check. Measurable, of course, yes. Stability, whether my software is stable enough, alright, with particular, maybe some parameters are there which, gets my software into unstable, gets my software unstable, right. So users does it, developers does it. And measurable, yes. Robustness, robustness means whether my particular software is going to be, is it robust? Robust means it can be implemented anywhere else also, right. And the code is robust, it can be changed or not, okay, it can be migrated somewhere or not, alright. Users does it, developers does it. Measurable, somewhat. Ease of use, whether my software is easy to use. My developers generally do not fall into that, but yes, my users, end users are the one who checks whether it is easy to use or not. Measurable, it is subjective, right. It is subjective means whether a particular software has certain functions which is, easy to use, but certain functions which is hard to use. So it is subjective. Then determinism, alright, both of them checks, user also checks, developer also checks. And measurable, yes. Back compatibility, alright, whether it is compatible to the back end whatsoever is there, end users check it, developers doesn't. Measurable, yes. Security, of course, we as a end user using any software, probably WhatsApp, we definitely check its whether it is secured or not, alright. So users does it, developers doesn't. And measurable, very, very difficult, because sometimes, if you say about Facebook for you it would be secure, for me it would be unsecured, right. So it is very difficult to measure. Power consumption, we generally check whether it is consuming more amount of power or not. Developers are not sufficiently interested into that, right. And difficult, it is difficult to measure whether it is measurable or not, it is difficult, right, power consumption. Then internal qualities, the criteria to be followed during internal qualities, again a table is there, just check the table. Again I have users, developers and measurable, and here you would be seeing that in internal quality whatsoever the parameters are there are my developers who check it, not my users, because internal quality is something which says that it depends on the code that we do, right, and of course my users are not going to code my software, it is we as a software engineers who would code the particular software, right. So internal quality generally is checked and coded by our developers. So here I have put a check only in the developer. Let us see, first is test coverage, alright. I said testability is one of the most important prime factor of my software to ensure my software quality, right. So test coverage, my developer does it, measurable, of course yes. Then testability, which is again the same, it is sometimes difficult to measure whether my test is passed or not, because if you find sometimes while running a particular code it is working properly, but when you implement somewhere else it has some bugs, it encounters some bugs, alright. So it is hard to measure. Portability, whether it can be used in one system and if it is portable to maybe some other system, if it is giving the same kind of work or not, alright. Portability, my developer does it, it is measurable somewhat. Thread safeness, alright, whether a particular thread is safe, it ensures that the other thread that is lead to, alright, maybe thread 1 to thread 2, maybe moving from thread 2 to maybe thread 3, is it safe enough or not, alright. My developer does it and it is hard to measure. Conciseness, whether my particular project is concise, right, my code is concise or not, measurable somewhat. Maintainability, of course my developers does the maintenance, right, we have already seen what is software maintenance, right, and it is hard to always measure it. Documentation also my developers only do and they are subjective, alright. Whether documentation is measurable, that means documentation has everything levied, whatever my software is providing with me, has it everything is documented, or maybe some points are missing, alright, it is subjective. Legibility, whether my particular software that I have developed is legible enough, again it is subjective to measure. And scalability means can I enhance more amount of code into my existing software code, alright, or maybe can I bring out addition of different features into my software which is already developed, alright. Of course it is measurable but somewhat, right. Let us see again that what are the necessary requirements for my software quality. Quality in software means that a product should meet all necessary requirements, which can be, what are the requirements, let us see one after the other. Problem for software systems, alright, it should say that if my quality is not up to mark, then what is the problem with my software system, why is it not providing better quality, right. Then second is shows discrepancy among customer quality and software developer requirements, alright. It says that if there is some miscommunication or maybe there are some discrepancies, maybe customer would have said you to provide certain features and we have not provided those kind of features, right. So any discrepancies among the customer quality, whatsoever the customer require and what we have provided as a software developer, alright, that is software developer requirements, alright, if they both are not matching, then there is a problem, alright. So it is required. Difficult to specify in a definite way, alright, it is very difficult to specify it in a very definite way, alright. We cannot define it, we cannot say that this is what quality will be given this much, this, no, it is very difficult to ensure such things, right. Then incomplete and inconsistent, alright, if my particular software is incomplete and it is inconsistent, right, then I cannot say it is going to be qualitative project, right. So in order to meet my quality, I should have requirement of a very complete one, a very concise one, alright, and a very good package, right. Then quality standards that are required to be followed during development are, what are the standards that are followed? First, product standards with features using components related to style of program or skills, alright, whether my product is proper or not, alright, it requires the skill of a programmer, alright. A programmer is the one who provides with the product standards, right, because if it is coded very haphazardly, it is not a good one, but if it is done with a proper coding manner, alright, with a proper maybe all the comments are given, right, that defines the product standards. Then process standards with features highlighting the process implementation. I have already designed a product, but this product will work according to maybe this many processes. Alright, so process standards with all the features of it and how to implement that process comes under process standards. Encompassing best practices to avoid previous mistakes. If there are any previous mistakes done during my software project, the development, software development, all those needs to be looked out, and a best practice to avoid those particular mistakes should be done. Designing as per organizational priorities with interference of new team members. Do not avoid your new team members, right? Whatsoever the new team members are there, you can always ask their ideas, all right? Maybe their idea would prove your software more amount of quality, right? Then quality standards are functional suitability, all right. It says that my particular software is qualitative if it is having all the functions, the required functions that an end user requires, right? All those functions that an end user requires, if it is provided, we call it as functional suitability, all right. Functionally it is suitable. Then reliability, my end user is of course going to rely on that particular software, so it should be highly secured, right? It should be reliable, so that also ensures my quality standard, all right. Then operability, wherever I go my software should be operable with me, it should be operated, all right. And if I am using software in PC1, if it's the same software I am using in PC2, it should be operable, right? It should work both the way, it should work similar, all right. So operability. Quality performance, right? It says that whenever I am using a particular software, the quality performance, that means the performance of my software should be very, very good, all right. So that ensures the quality performance. Then security, as said, if I am relying on my software, it should be highly secured, right? Then compatibility, if I am using it in some other maybe operating system, and if the same software I use in some other operating system, right? So it was designed maybe for Windows operating system, but the same software if I want to use it with maybe iOS operating system, right? Then in that case I need to see it's compatible, whether it is compatible or not. So your software, if it is qualitative, it should be compatible with any kind of operating systems, right? Then maintainability, my software should provide me with maintenance facility. If any problem exist or persist in my software, then it should be maintained very, very easily, maintainability. Then transferability, if I want to transfer my software from maybe one OS to other, or maybe from one system to the other system, maybe from one organization to maybe its sister organization, it should be transferable, right? So all this are quality standards, all right. Now for this quality standards, I would like to quote one example which will help you to understand all these standards, all right. Talk about your WhatsApp, all right. WhatsApp provides you with all the functions, yes. You rely on WhatsApp, yes. You rely because it is very much secured, yes. Quality performance, it is not like WhatsApp will not work when you wake up at 3 AM in the night. It will work the same way as it is working in the morning time, right? So quality performance is there. Operability, it is operable maybe in your your particular Android phone, it is operable in your Windows phone, it is operable in your iPhone also, all right. So it is operable everywhere. It is compatible, that shows it is compatible with any operating system of your mobile phone, right? Maintainability, you can maintain it very, very easily. The only thing is you need to upgrade it whenever the upgraded version is there, it is upgraded, right? Maintainability. And transferability, you can transfer it very, very easily from one phone to another phone. For example, if you have been using maybe some Samsung phone, and if you want to put the if you change a phone, right, then in the particular other phone also your WhatsApp can work easily, right? So it is transferable. So all this, for this particular, you can take up example of your WhatsApp, right, which will help you to easily remember the standards. Now a quality model has following features. What are the features for a quality model? First is effectiveness, my particular software should be highly effective, all right, then only I can prove it is a qualitative product. Then efficiency, if I say that my software will not work properly in maybe so and so environment, I cannot say it is efficient, right? So, in order to check whether my particular software is highly qualitative, I have to measure its efficiency also, it should be highly efficient. Then satisfaction, customer satisfaction is the one which is very much utmost required. If you are building any software, alright, and if your customer is not satisfied with that software, alright, then I cannot, you know, tell or claim that my particular software is very qualitative. No, it depends all on the satisfaction of the customers. Right, safety, my customer always looks for the a secured kind of software, right, so safety should be there, right. Usability, all right, my software is providing me with n number of users, all those n number of users should also be there, you know, I mean it should be you know, legibly there, all right, so it should be usable, reusable any a time, right, so usability, all right, so all this ensures my qualitative software. Alright, so a quality model has following features. So, all these 5 features should be there inside your software that you develop, alright, to make your product a particular, you know, or to reach it to a particular quality. Alright. Next is verification and validation. We generally refer this as V and V, right, V and V. So, verification versus validation. Now, what is verification? What is validation? Alright, so they both are actually different term and they are called as methodologies. Right. So, verification and validation is a methodology that will find and assess correctness and standard of quality in software all the way in software life cycle. Alright, they are the one who assess your correctness and the standard of quality. Alright, so it says that verification always checks on you know, whether my particular project that I am doing is correct or not, that is verification. Alright, for example, you write a particular paper, right, when you give a test or maybe you write an exam, alright, it is verified by your user whether it is correctly written or it is incorrect, right, so that is verification. Validation, whatsoever we are doing, alright, is to meet some certain quality, are we going to, you know, is it validated, alright, that is called as validation. Verification is a process of finding the development phase work products of software development and to check whether the verification is done in right track at a time of creating the final product, to check whether my particular project is reaching properly at a particular time frame, right, whether it is following in a particular time frame, alright, that all comes under verification process. While validation on the other hand is a process which finds out whether the software is meeting the required business needs during the final product, that ensures that whether whatsoever my customer requirements were there, right, is my particular software fulfilling all those customer requirements or not, comes under validation, right. Then it shows range of values such as, what are its values, just check. First is complexity in the software, whether my particular software is highly complex, it includes the size complexity also, right. Then next is criticality, whether my software can work under critical situations also, or maybe it is dumped, you know, or maybe it ends up abruptly in certain critical situations, right. So, criticality is there. Then risk, whether it is able to take up the risk or it is avoiding those risks, it is preventing those risks, or maybe it is detecting the risk and maybe it is working still fine with it, alright, that all ensures the software quality. Then level of safety, what kind of level of safety it is providing, my particular software is providing, right. Then level of security, right, what kind of security it provides, right. Required performance, whether all the performance that is required by my customer is provided within my software or not, all comes under, you know, these are the values that is there. And lastly, reliability, right, as said, my particular any of the software that I take up, right, it should be reliable, right. I cannot use my software as it is, right, if it is not reliable, nobody is going to use your software, right. So, next is, just check this diagram, alright. Verification and validation, have we built the software right? Whatsoever software we are supposed to build up, is that software built right, is called as verification. And have we built the right software? Whether some other software was required and we have ended up building some other kind of software, whether it is correct one, is called as validation. So, verification and validation is something that, alright. Now, 1 minute. This methodology, what the verification and validation methodology uses following techniques to verify your software. First one is peer reviews. Peer reviews means if for example, when you are writing a paper, you would be saying that marks are written, and down there it is written verifier 1, verifier 2, right. So it says that a paper checker is there, the examiner checks your paper, alright, and whether that particular paper is checked properly or not is verified by some other verifier, maybe verifier 1, verifier 2, right. So peer reviews is nothing but review that we gather from our peer mates. Peer mates means our colleagues, whether this is particularly reaching in a proper time, whether whatever we are developing is proper, right, whether it is requiring any changes to be there, is called as peer reviews. Then documentation inspections, whatever documentation we are doing, right, we have to inspect those documentations, right. Then requirements design, the code reading, alright. So whatever I do designing, alright, I ask my particular person or a colleague that whether this design is proper, whether the code that I have done is proper or not, right. So that checking is done. Then test witnessing, right, I ask some other testers who would test my application or my software that I have done, alright. So test witnessing is there, and they witness whether this test is proper, whether this software is proper or not, alright. Then installation audits, I check up whether this particular software that I have done requires some certain external installation, or maybe installation of some tools that is required external to it, alright. That is installation audits, alright. V&V is done in every phases of life cycle, such as planning, requirement, design, implementation, testing, installation and checkout, operation, alright, and lastly maintenance. Now if you see this, all these plans are nothing but my entire software life cycle, right. So my life cycle starts with planning. So verification and validation is done whether plan is proper or not, whether the requirements that my customer gives up are proper, are legible, are proper or not, whether the design that I establish on the basis of my requirements that I have analyzed with my users or with my customers, alright, I lay out on maybe a sketch paper or a rough sketch, or maybe through certain other tools, right, like case tools, right. So that designing is done. Then implementation, I start now coding of that particular design, okay, I start preparing my source code, is implementation. Once I have done my source code, I will give it to a tester to test out whether my source code is proper or not, that is testing phase. Then installation and checkout, alright, in order to reach my particular or work my particular software very easily, I need some certain sort of installations, maybe an external one, maybe an internal one, alright, and I check out with that. Then I do the operation management of it, right, whether my particular software is working properly in PC1, but if it is not working properly with PC2, what is deficiency in that, what are the discrepancies found, alright. So operation, and lastly it is maintenance, right. Once I have given it to my customers, I have sold out my software to customer, right, I need to maintain it, right. So that is maintenance part, right. So my verification and validation works with all these steps, right. Then let us see what are the benefits of V&V. One can locate leads much before in order to create better solution instead of fixing them later on, alright. So if I have certain problem with my software development, if I find that I am not going on a right way, right, then V&V provides me with that particular assumption that yes, I am not going right, it gives me result, it gives me output that I am not building a right software, alright. Then one can find the solution using correct problem against software needs, whatever the software needs are there, the customer requirements are there. If you are not fulfilling those customer requirements, then it helps you to give the solutions. It shows objective evidence of software and system fulfillment in terms of quality standards, right. So whatever the quality standards are there, all those are getting fulfilled or not also is evaluated by your V&V, Alright, then shows process improvements along with feedback on quality of development process and products. So it shows the process improvements along with feedback. So whatsoever I said peer reviews are there, right, whether your particular product that you have developed is proper or not. Alright, so all that comes under with the feedback. Alright, and there is a process which helps you in building a better quality product. Alright, so V&V has certain benefits. Alright. This is it with unit 1 right now. Alright, we will continue with unit 1, the further parts of maybe planning and all. We will look at what are the software quality types, alright, and its standards, alright, how to manage it, what are its processes, alright, what is quality control. We will see all this in the next session. That is it with it. Thank you.